Hello, I am Rajit Shah from Big Data team of VMware R&D. In this video, we are going to discuss about the resource isolation in a multi-tenant system created by Big Data Extension. The content of this video is subdivided in two different parts. One is multi-tenant system, another is resource isolation. So in the multi-tenant system, we will see how to create a multi-tenant system inside Big Data Extension of VMware Data Center. And we can see how execution of parallel workload can be done in different big data components like Hadoop, HBase, and those. In the second part of the video, we will see like how the resource isolation is made by big data extension and for these different big data components, how we can change, we can manage, we can reallocate resources to a different subsystem. And after changing those resource allocation, we can see what is the effect of resource share in different big data component like Hadoop and HBase system. Let's see how a multi-tenant system can be built on top of VMware Data Center. So a VMware Data Center is consisting of multiple ESX hosts. Each of the hosts is connected to local disk as well as a shared storage. Data center can be subdivided into DRS clusters. Each DRS cluster can have multiple resource pools which can be dynamic. We will talk about the resource pools later half of this video. Initially, we will talk about the multi-tenant system how we have created on top of VMware Data Center. We have two kind of systems. One is big data systems, another is the non-big data systems. In the big data systems, we have created the multi-tenant system by big data extension. Here we have created one HBase cluster and another set of Hadoop clusters. These three Hadoop clusters is basically creating another sub multi-tenant system where we have only one HDFS cluster which has data nodes and name nodes, another two compute only clusters which are having only task trackers and job tracker, and two compute only clusters are sharing data from same HDFS cluster. Now let's create the multi-tenant system by Big Data Extension. This is my vSphere web client and here we have the Big Data Extension running, and let's create some cluster. Let me create a cluster called HBase cluster. And I have one data node master, one compute node master, and one HBase master, and three worker node and one client node. And I'll keep this cluster inside the big data resource pool. Let me create another cluster called HDFS cluster. This is my spec for HDFS only cluster. I have only Hadoop name node and I have data node. There is no job tracker or there is no task tracker, and we have Hadoop client. Let me put it in the same resource pool called big data resource pool. And let me create the cluster. Now let me create two compute only cluster. One is for devs, another is for tests. I have to put the number of worker nodes, number of client nodes, and those kind of stuff. And let me put in the same resource pool called big data RP. And let me create that cluster. Now I'm creating another Hadoop compute cluster, and that is for test team. This is my compute only cluster. Let me put it in the same resource pool called big data resource pool. Created a multi-tenant system with one HBase cluster, one Hadoop data node cluster, one Hadoop compute node cluster for test team, and one Hadoop compute node cluster for dev team. Now we will see the parallel execution of Hadoop and HBase jobs in this multi-tenant system. Now we can see that how in parallel multiple executions of Hadoop and HBase job can happen in a multi-tenant system. Let's start a HBase job first. We are running a random writer job of 12 clients. So let it run. Now we will see the Hadoop clusters. So this is my HDFS only cluster. So now I can see there is nothing inside user Serengeti. Now we will run some Terragen job in one of the compute only cluster, and we will see the data will be populated inside the HDFS. So this is the Hadoop client for one compute only cluster. Now I have started a Terragen job in one of the compute only clusters client. Now we will see what is the status of HDFS cluster. You can see the HDFS has user Serengeti Terragen. That means this compute only cluster is putting data in the common HDFS cluster. Now, as we have created the input data for TerraSort by TerraGen job, which is residing in HDFS, we can run TerraSort from both the compute only clusters using that same TerraGen input directory. So I'm running a TerraSort job in dev system right now, and I'm running a TerraSort job in test system as well. So now you can see three jobs are running in parallel. One is HBase in HBase cluster. Two TerraSort jobs are running in two different compute only clusters. So this is the way we can basically run Hadoop workload and HBase workload in parallel in multi-tenant system. Now we will see the resource isolation part of this video. Now here we'll see how the resource isolation is made by BDE and how we can manage and reallocate the resources in different subsystems like Hadoop and HBase. And also we will see, like, by changing the resource allocation in different subsystem, how the workload will be behaving and how the resource will be utilized by those clusters. Let's go back to the old picture. On top of this ESX data center, the whole resource is divided in two different top level resource pool. One is big data resource pool, another is non-big data resource pool. In the top big data resource pool, we have four child resource pools. Each of these child resource pools are basically managing each of the Hadoop clusters and HBase clusters. These resource pools are dynamic, like we can change the resources utilized by each of the cluster by changing some parameter in the resource pool, like changing the share, reservation, and the limit. Now let's see the whole system in VC Web Client. We have the big data resource pool and a non-big data resource pool. And in big data resource pool, we have created all these different clusters, compute only clusters, HDFS clusters, or HBase clusters by big data extension. When big data extension creates a Hadoop cluster or HBase cluster, it creates under a top level resource pool. By creating a cluster under a top level resource pool, isolate the resource utilization from the other clusters. Big data extension not only isolate the total amount of resources utilized from the other cluster, it also create a sub resource pools for the different VMs. We have client, we have master, and we have some worker nodes. And for each of the node group, big data extension create a separate resource pools. Now we will see how to manage resources for a particular Hadoop or HBase clusters created by big data extension. So now if you click on this resource pool, and there is a edit settings, and it shows like you can change the resources, reservation, share, and the limit for CPU and memory. By changing the reservation and resource pool limit, you hard limit on maximum and minimum utilization of a particular resource for this particular resource pool. Whereas changing share is more indefinite, and if you put a normal share in all of your three clusters, then total amount of resources equally divided across the three clusters. Now if you put shares as low, then the CPU utilization for that particular resource pool will be less compared to other resource pool available in the data center or the DRS cluster. Similarly, if you put a high share for a particular resource pool, then it will consume more resources than other resource pools. Now we will see the effect of resource pool share change on Hadoop and HBase workload. Initially, we will set normal share for all the clusters, and then we will put HBase cluster high share and all other cluster as low share, and we will see how the execution happens and how the CPU utilization of HBase cluster increases. Now, these all top level resource pools are in the normal share, and all the clusters are running some Hadoop and HBase workload. Let's see the CPU utilization of a HBase worker node. So it is around 40%. Now let's see the CPU utilization of a Hadoop compute node. This is also consuming 40% of CPU. Now let's change the resource pool share of the clusters. We will change the HBase cluster resource pool share high for CPU and all other clusters as low. So now we have HBase cluster with the resource pool setting of high CPU share, and all other Hadoop clusters are having low CPU share. Now let's wait and see like how the CPU utilization is happening in all those clusters. Now we can see in one of the worker node of edge-based cluster is having more CPU utilization than before. So as a conclusion, we can see that VMware Big Data Extension provide the solution for creating a multi-tenant system, as well as you can do the resource isolation in the multi-tenant system, and you can change the resource allocation and manage the resource utilization for all these big data system.